So in activity 4.2, we're going to compare equations and tables. And here's the scenario. Josh and Greg are friends who live in different countries. When they chat online and talk about the weather, one of them uses Celsius, one of them uses Fahrenheit. Josh uses an equation to convert Greg's temperatures, and Greg looks at a table to convert Josh's temperatures. The equation and part of the table are shown. So when Josh is talking to Greg, Greg is going to use that table to help him figure out what temperature Josh is even talking about. And then when Greg is talking about temperature, Josh plugs whatever Greg says into his equation to figure out what that temperature means in regards to his system or his temperature format. So remember over here, we've got 0 degrees Celsius is the same thing as 32 degrees Fahrenheit. Question 1 says, identify the quantities in the table and the equation, and who's converting from Celsius to Fahrenheit and Fahrenheit to Celsius. So I'm not really sure if I look at Greg's table, that one's not as easy to understand to me. But if I look at Josh's equation, I see 32 there. And if you look over at the bubble that I circled on the left side, I'm wondering if 32 is a coincidence or if that's there on purpose. So what if I plugged 0 in for x? So j of x equals 9/5 times 0 plus 32. So whether that 0 is Fahrenheit or Celsius, let's see what the output is. That ends up just being 32 on this side. So when I plug 0 in, I get 32. So it looks like we are going from Celsius to Fahrenheit with Josh's equation. So Josh must live in a country that uses Celsius. And so when Greg tells him it's 100 degrees outside, Josh will put that into his equation to figure out what that means in Celsius. So that means that Greg's goes from Fahrenheit to Celsius. So when Josh tells him it's 25 degrees, which is really hot actually in Celsius, Greg will plug that into his table to try to figure out what that means in Fahrenheit. All right. Oh my. Oh, sorry, guys. Okay, question 2 is saying compare the given characteristics for each function in terms of the quantities. So this one's a little harder. So Josh, if we want to look at slope, well, his is the equation. If you scroll back up, that one's pretty easy. It's in the M spot here. Sorry, you can't see it when I do that. So it looks like the slope for Josh's equation would be 9/5. And then Greg's equation, or Greg's graph or table, it's a little harder to see, and they kind of round in the table. So I'm just going to tell you it's flipped, and it's 5/9. Okay. And then what does the y-intercept mean? So let's go back to Josh's equation. It's a little easier again to see the y-intercept. So if you look here, the y-intercept is 32. So if we have to talk about what that y-intercept means, that would mean that when degrees Celsius is at 0, Fahrenheit is at 32. Okay, so if we write that in here, 1 degrees Celsius equals 0, Fahrenheit equals 32. And then Greg is a little trickier again, and I'm going to give you what his is so you can get it into your workbook. Greg's y-intercept, if you were to extend your table, is negative 17.75. And what that means is when Fahrenheit is 0, Celsius is negative 17.75. So that would be like Greg being on the phone with Josh and saying it's 0 degrees here. And Josh would say, okay, well, what is that? He'd plug it into his equation and he'd figure out that that means about negative 18 degrees.